Good morning to everyone. This is Dr. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical in Hyderabad. So I'm very delighted to share my thoughts on today's topic, that is the application of digital image processing. So this is the topic which we are in continuation from the subject of image processing. So why I have chosen this topic? Because this topic is completely depends upon the various applications. That means the image processing which we are concentrated the concepts towards to fulfill the proof of the concepts, towards to fulfill the proof of the concept. The concepts compulsory have to apply to the application. So what are the application can you able to find? So can you able to apply your learned concept? Okay. So how you may be concentrate such a complete concept to prove yourself as a knowledge person of the image processor. So this image processing is never end actually. This image processing concepts and image processing knowledge which we are going to be applied to the various application, it's not be end. It's not be keeping only limited application. That is the meaning what I want to share with you today. So it is fixed to towards to apply inter or multidisciplinary applications, inter or multidisciplinary areas. So that means if at all we concentrated on image processing, so you are the one of the important person whom we can able to apply your concepts towards to everywhere, any field. Okay, but why we are concentrating such a way towards to fulfill your knowledge as towards to prove as a courage knowledge person, in the sense here your applied is faithful knowledge information. To whom, to where we are applying are, let me to share some of the application which I am listed on today towards to connect you for applying your learned concept to the applications. What are those? Number one, we may be apply that your digital image processing knowledge to the image sharpening and restoration. Number two, medical image processing. Number three, surveillance. Number four, law enforcement. Number five, artistic effects. Number six, mission or robot vision. And next one is color image processing, color processing, video processing. So these are the various applications which are not be connected, not be concentrated on single what we called not connected in a single area. It is it is interdisciplinary. It is interdisciplinary areas. It is multidisciplinary areas. So that areas which we are going to be apply here, if you see compared to these two, these are all not be fixed with one area. Compared to surveillance to the medical image processing is too different. Both are too different. Once is both are too different, but how you may applied a single concept which you learned as image processing, which we are want to apply here in terms of medical image processing towards to the surveillance. Okay, so that is what we wanted to understand from this slide. So your learned concept can be applied to the various list of applications. So that is very important. That is very important here. So coming to the if we wanted to apply such a concept which is you learned, let me to revise, let me to recall such a concept which you learned to apply to the your towards to any application, towards to the particular your selected application. So what you want to recall here? That means what do you mean of digital image processing? What we mean digital image processing, DIP. digital image, DIP, DIP, digital image processing. How we may be refer that processing digital image by means of digital computer. By means of computer. So that means you select this as one of the field. You select this as one of the field. One of the field. What we have to say? It is one of the field. Which field? It is completely digital field. Which field? It is completely digital field. So being it is a digital field, we are compulsory concentrating on the digital computer process only. Completely concentrating on the digital image processing only. So it means that an image may be defined as the two-dimensional function, that is f of x comma y is a two-dimensional. Okay, so which we are already discussed with the help of a spatial plane, with the help of spatial coordinates, nothing but plane coordinates. So the amplitude of at the any pair of the coordinates x comma y is called intensity or gray level of the image at that point. So at that means if you take this, so this is y-axis, this is x-axis. The in between these two are various, we call as a spatial coordinates. Spatial coordinate plane. This is your plane. This is your plane. So this plane we can take the 2D image. Okay, being it is 2D image. Being it is 2D image. Okay, so such a 2D image which we are going to be concentrating on here, we are 100% concentrating. 100% concentrating is towards to concentrate on the intensity or gray level of the image at that point. So this intensity varies is also we can consider as one of the crucial or critical point. Crucial or critical point of the. So when x comma y and the amplitude values of f all finite discrete quantities, we all call the image as we call the digital image. Why? Because the finite values which are in terms of discrete quantities, which are called discrete quantities. So coming to the point, I am extending the basic knowledge, that is the origin of the digital image processing. That origin of the digital image processing. How we are extending in the sense, you are going to be concentrating of a finite number of elements, each of which particular location and the value from the digital image. Why? Because once you understand digital image is nothing but a discrete quantities values in the form in terms of f of x comma y. F of x comma y is the objective function of the digital image, which we are going to be used towards to play vital role towards to find in terms of location and value of the image. What are the values of the image you want to concentrate? One I said from the previous slide, intensity of the image or gray levels of the image, which we are going to be vary. In that intensity of the pixel, intensity of such a digital image, how it is are varying in terms of various values. In the sense, we are going to be keeping such a image elements nothing but pulse and pixels. So what do we want to say? These elements are referred to as picture elements. Number 1, number 2 image elements, number 3 pulse, and number 4 pixels. Once we understood this all 4 relationships, 4 elements of the relationships, then easily we can prepare a solution of the digital image processing for various applications, or your selected image, or you have selected the particular application. So what do you mean that? That means pixel is the term mostly widely used to denote the elements of the digital image. If you take the image, this image is right now under the x-axis and y-axis. So the image is here. That means the values are what are the image values are depends on y-axis and x-axis. That means each and every pixel value is here. is here. Is here. Each and every pixel value is here. So that value is how it may be vary. It's a connecting with the, or it depends on the intensity of the image, the intensity of the pixel value. So how, in this sense, you take this image, okay, this is image, okay, continuation. So you take this images on x-axis versus y-axis. Okay. These values of the image values are varies. These image values are varying in terms of pixels of the intensity. In terms of pixels of the intensity. So the pixels. These pixel element values we are going to be concentrated. We are going to be varying. What do you mean to understand about varying of these pixel values? In the sense, you are keeping your image in the form of matrix. The form of matrix. So that matrix values are vary m by n. M by n. So all values of the image values are varies m by n. M by n in the sense number of pixels in rows, number of pixels in the columns, which we are going to calculate. Okay, so that is very important is here. Next, coming to the, let me to take one image, which is here medical image. Medical image. I wanted to keep this medical image a number of pixels. It is a relationship with the number of pixels and number of rows. Number of pixels and number of rows. So what do you mean to concentrate on number of pixels and in this image? In the sense, you want to concentrate such a medical image towards to keeping that image towards to assistant to the doctor. So why we wanted to assistant that medical image towards to the doctor, in the sense that image which we are processing towards to concentrate a doctor for finding the fault in the image, finding the for the detailed diagnosis in the image, because it is a medical image. Then what is that you are providing to the, or you are keeping that image processing in terms of or towards to research assistant to the doctor, in the sense you make that image in terms of enhancement. That is what I am taking example here. So after you understood the basic concept as nothing but a digital image, we are connecting that digital image with one example by taking one of the application example is medical image. So I taken here is, by seeing this, we can understand by seeing this, it is one of the medical image. It is one of the city image. So this image we are going to be processed to understand in terms of here this is there. So in terms of enhancement. In terms of enhancement. What do you want to enhancement? In the sense, you are priming the toward in terms of applying digital image processing techniques for improving the quality and remove the noise in the image. That is called image enhancement. For example, you have a motherboard. This is motherboard of a computer. It's a board. What do you want to understand this board? You are going to be enhanced here. What do you mean to understand here is, you are going to be concentrated here is enhancement. That means each and every component on the image and what we call in that particular process, okay, particular process, we are going to be concentrated on particular process, okay, towards to finding the components which are not connected properly. That means previous example is your image processing, concentrating in terms of medical image processing application. That means your image processing, systematic image processing right now assistant to the doctor. But right today, now itself, we change the other field. Other field in the sense, we are going to be seeing the engineering. Engineering means electronic engineering. So a different field. It is medical field is one field compared to the what we call motherboard processing, finding there by the image processing in the sense, it is another engineering. That is called engineering. This is non-engineering, that is engineering. It is a medicine, it is purely engineering application. So that means you are concentrating not only one particular application of the image processing. You can concentrate multiple ways. You can concentrate in number of applications. So say take surveillance. This is surveillance. So what is this surveillance? You are concentrating that a complete map, and you are going to find, see this after enhance how you are finding the information. Is it, you can understand that this before enhancement information is not clear, but here it is clear. That means your concentrated here is improve the quality analysis of the image processing. How we are applying that? So you are one of the important person whom to understand the requirement of the image processing, and you are applying to the such image requirement towards to the your selected application by using digital image processing techniques. But we'll go to use here one more application I wanted to take as example is it is artistic effects. Artistic effects means movies, art preparations. So every movie behind there are the process of artistic process. So manually that artistic process which we are processing is not fixed. It is obviously may changes one effect to the another effect. So nowadays you maybe have gone through so many movies. The movies which they are preparing completely by using our digital image processing card only. Completely they are using our digital image processing techniques for preparing the requirement of the artistic effects, more effects. So you see, if you see here how they are discussing what are the effects we want to apply here, like that they are discussing. So that means you are making the image more usual appearing to add special effects and to make the composite image process. So such a one what we want to concentrate is here. So for example, I will take another example which is in the continuation of previous example, that is medical image processing. I have taken one of the image. It is a MRI image. What do you mean MRI? Magnetic resonance imaging. That is scan of your heart and find the boundaries between types of tissue. The tissue parts you are finding. And image with gray levels representing tissue density. And you are going to find out that suitable filter to highlight the edges of your particular image where you are concentrating tissue, the size of the tissue. Is it the tissue is growing stage, or it is what the stage? It is in the stage of cancering process. What is that actually? How you want to concentrate that? So that means you want to take this MRI image towards to find us various parameters of the values, because here simply doctor can find what is the affecting in the particular image based on particular image information, but you want to do more quality analysis, he cannot. So there we required this image processing. There you require digital image processing. we are preparing such image processing in terms of digitization process. So once that scanning happen, the scanned image may going to be inserted into your prepared programming. That image processing program will going to be processed and give to the required information. We are going to discuss that with the various applications that you can see here in the coming slides also. Let me to take other application which is 100% civil department. Civil department or 100% the image processing which we are applying here, disaster management process. So how we are going to be applying here? GIS means Geographic Information Systems. This is the GIS. So what we wanted to concentrate here is extensionally to manipulate the satellite imagery and terrain classification and meteorological data, meteorology data analysis. So what we want to understand is here, you are going to find out the part of information which is what required to the required towards to analysis of in terms of remote sensing process. See there, I am not concentrated by image processing which at one end or which at one application. I am extended that to various applications. How it is possible? Because of it is possible, you learned this image processing to outsupply to the various applications. Next, coming to the other important application that what we called law enforcement application. Law enforcement. So what we want to concentrate is here, law enforcement means where we can concentrate such a law enforcement process by using image processing is mostly we can use 100% in traffic control process, or to find out the accidents, or to find out the vehicle numbers which are in troubling others, which are not in control, not in the control of such a vehicles. So what do you mean to understand here is you are going to be concentrate such a process. You are compared to one image with the other image. Okay, is it not be clear? But by applying your image processing, you can apply, you can recognize your number plate of the vehicle. Even it is very speed process. So that means your cameras are fixed automatically to all the system process. Next, coming to the not only this type of processing, but we can take this law enforcement in terms of today that complete bank sectors are using this law enforcement process using image processing. What is that? Is fingerprinting recognition process everywhere. So this fingerprinting image processing is mostly you are going to be used in terms of your digital image processing, because we have to understand that the fingerprinting compared to one another is 100% different. Even in one family, the one family of the fingerprints are not the same to the same family members, even though they are born and brought up in the same family, but the fingerprints are different. Similarly, eye retina process also. So can you understand here how this law enforcement preparing with the help of image processing? In a simple manner, we can achieve the difficulties. That means you can say simply by the help of this slide, image processing will do the miracles. So it helps us towards to develop various applications in law enforcement towards to assistant to the lawyers and judges. That is the technology today they are using in our law enforcement process. So coming to the HCI. So you are going to be use this HCI means H means human, C means computer, I means interfaces. HCI application. So that is the extension of your application of image processing is not fixed with one. it is extended. That means your HCI, human-computer interface, is more natural. That is face recognition, gesture recognition. So does anyone remember the user interface from the minority report? So you are going to be concentrated. The task can be extremely difficult. Extremely difficult. So what we want to concentrate is here is you are going to see these all images which we can see that how the computer is interface with the human. You want to find out the human, whether that human being is the person can be allowed into the various important places. Okay, some VIP places you may be observed. One of the place which we can be categorized into VVIP, VIP, and the assistance members, media persons, next audience, next general person, outers, security, categorizations. So how can you categorize that in a simple process? By the image processing towards to connect your human with the computer interfaces, then it can recognize the process based on the program which we prepared. It can be recognized easily and categorized in a particular place. For that, we are using this what we call the HCI process. What we call that HCI process. So coming to the next, this image processing can be extended in the various fields. Various fields. Number one, computer graphics. Number two, the image processing which we are going to be keeping in other manipulator of the image. Number three, computer vision. What do you mean computer vision? Analysis of the image content. So that means you are concentrating here such computer graphics also creation of images for various reasons, for various purposes. So that is very important here. For example, you take computer vision. For example, continuation. Computer vision. So computer vision will be useful right now. Today we are going to be apply image processing towards to prepare the computer vision, robot vision. And we are going to apply the computer vision in a visualization process. And we are going to apply the computer vision in terms of what we call that the HCI. We can apply towards MCI. MCA means mission. What do you mean this? Sorry, MCA, not MCA. B. It is BMI. BMI. Brain Mission Interface. Human Computer Interface. This is also called as Human Mission Interface. HMI. So what are these? These are we will prepare such a application. So we can extend our the concepts of the image processing from the basic fundamentals of the image diagram, that is knowledge based diagram. This block diagram will be help us towards to extend various application, towards to extend this image processing, towards to connect to the various application because of this all the blocks connected. So that means once we are applying this block diagram, it is we call as knowledge based image processing of knowledge based block diagram is we are applying once we have the knowledge about the image processing, and also once we have the where we can apply this image processing to the various application knowledge. There also we have to have the knowledge. Until unless we doesn't have the knowledge, if does not have the knowledge about any application, any field, we cannot apply this image processing. That's what I want to share about this block diagram. So what are this block diagram says? Firstly, we can say image acquisition, Secondly, image enhancement, image restoration, color image processing, wavelets and multi-resolution processing, and image compression, morphology image processing, segmentation of the image processing, object recognition, representation and description of the image. So, these all various blocks of the concepts which we can apply towards to prove the proof of the concept towards the applications. So that means, for example, you are taking one system. This is system. Continuation. What is this system? You prepare this system based on the knowledge based. So how you are preparing this knowledge based system? Because you are find out some faults. How you find out? Because you are applied some input data sets to the system and you got your output data sets. And now how you got these false data sets? How you got these false? Because you are compared that output data sets with the target data, which is desired. This is desired data. This is your target data. This is your expected, your output. Expected output. Expected output. So your prepared program is here. You are going to find based on your applied knowledge based image processing. Okay, so that is very important. So how we are applying? Let us take this one example. You take the image data set image and you are processing that in our system. This is system. Where you want to process, what application you output you want. This is output. This is input. What is your expected output? How you are going to be find that? So based on your acquisition, image enhancement, image restoration, morphological processing, segmentation, object recognition, representation description, image compression, color image processing. So I replace the image to the other image. What I want to concentrate enhancement. See that from the image whether I have been enhanced or not. So similarly restoration. Let you can understand restoration means the data which is missing here can be observed in your required image process. You see here you are going to be morphological processing. That is, you are going to be recognize the process. Recognize the process. What you are recognizing here? Who's them? This. How you are going to be understand? It is all process of under the morphology. Next, you are going to be apply segmentation. You are finding the segmentation means segment is nothing but separate groups. You are grouping that. From the image, you are separating the groups. So this is one, this is one, this is another. By the grouping of your pixels of the image, you can understand is there any repetition of the pixels in that. Then due to that repetition, redundancy is more. It's becoming redundancy more. That redundancy you are going to be reduced by using image segmentation. We are going to discuss in detail in next classes. Don't worry. But how we are applying this image processing to the various field is very important here. You are going to be recognize your objectives. You are going to be classify these objects by using the object recognition. So coming to the representation and description. So we are going to be find out your data set. You are going to be find out your data points that you are going to represent in description. You are going to be see the compression data. how your see compressed data, your original image and your compressed, how it is transformed one size to the other. Original size is how much and what type, then how it is various. Similarly, last but not least, how this fundamental image processing can apply to the various application, that is color image processing also. Today, everywhere, anywhere, anything, any movies are right now concentrated on color image processing. That's what you can convert your black and white to color image processing also. So with this, I'm closing my our discussion on how we can concentrate our learned concept towards to apply to the various application. So even we can find some more application of the process by the referring of some of the textbooks. I've been preparedly, that means as per our syllabus, there were two of the prescribed books which I have been listed out here for your reference. And from these reference books only, I referred our complete today video lecture also. I want to say thank you to everyone for your patient listening, and you can. I hope you are understood it, the complete discussion from one slide to the other slides, so we can connect our video lecture, not only this, from the next video also in the continuation. Okay, and thank you so much. Thank you. I'm stopping here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.